Morning, everyone. Everybody ready for Project 4? Since you got Project 3 done so long ago. Got the big weekend break. Any questions in general before we kind of go over a little bit about Project 4? Nothing? I didn't see a restriction on that, so I would assume so, yeah.
The last time says, please note that your editor must not create or read any file.
Yeah.
So, is that related to not using C++?
No. What I think that has to do with is somebody creatively solved the Project 3. I don't know if this is exactly true, but basically they used external files instead of data structures. So they used files to kind of be their data structure, and the testing mechanism that's on the server didn't know how to deal with that. Basically, wasn't prepared for that. So instead of going through and fixing how the testing works, they added a line that said that you're not allowed to do that. Any other questions? So, what's the difference between no, let me back up. How do I want to do this? So, in C we have explicit variables, right? You have to define every variable before you can use it. If you use or make reference to some variable that's not defined, you're going to get an error. There are other languages, though, like Python, Visual Basic. There are a whole host of them where you don't have to define variables before you use them. You just start using the variable, and the compiler kind of figures it out. Those would be called implicit or implied variables. So you don't have to define them or anything, and there's a lot more work that the compiler has to actually do. At the same time, we have in C the capability to redefine types or to make them bigger. I mean, Adam talked about in class that you can use a struct and have multiple types within there, or objects in C++ would be similar. And you're basically taking types and just redefining them. For this project, you can explicitly define or redefine types. It seems kind of basic. Instead of doing int, you can't have multiple in there. You're just taking int and you're saying, well, this is now my int type. So you're just kind of copying it, if you will. But don't worry, it'll get complex enough going through all of this stuff. Because what you can also do in this language that they've created for you guys to parse is you can do implied types, which means instead of having an actual definition for something, you can use it in the variable declaration, some type that hasn't been defined anywhere else. It's not a built-in type, hasn't been defined anywhere else, and your program, at least semantically, has to determine what kind of type that is if it's possible. So you kind of have four different flavors there. You've got implied or explicit types, you've got implied types, you've got explicit variables and implied variables. You will find implied types in the variable declaration section. So they won't have been defined anywhere above, and you'll find them in the variable declaration section when they're used on the right-hand side. Now, with implied variables, you won't find those in the variable declaration section. Instead, they'll just be used in the program body. All right, so with that kind of said, what I want to do is kind of step through, at least to start with, the description of the grammar. And I've got this example over on the right-hand side so that we can kind of look at how the input here, how it kind of equates to, so on the right-hand side, this is a sample input that would come in your program, and on the left-hand side, we just want to look how it matches up to the grammar description. So we start at the top level. You've got the program, which has got the declaration portion or section and a body. Now, over here, if we keep going, the decal section is broken down into the type declaration section and the variable declaration section. And we can kind of see these right here. That's those two, the type declaration section and the variable declaration section. Now, within the type declaration section, does it have to exist? Do we have to have a type declaration section?
Yeah, it's not stop.
Over here,
Yeah.
you have type and then type declaration list. But we also have this guy.
Oh, it goes in.
Yeah, so we could, this would also be a completely valid program. It doesn't have the type declaration section. Now, within, once you do have a type declaration section, then you have a type declaration list. And the list is made up of either one or many, this would be the case for many, type declarations. So that would be this guy right here. This is a type declaration. And then within a type declaration, you can have an ID list, which means down here we have one or many IDs separated by commas if there's more than one. So that example of that ID list would be right here. So that matches up to this. Then we have a colon in between and the type name, and ended with a semicolon. Make sense? For the type declaration section. And then it's pretty much the same thing for the variable declaration section. No, I'm going to back up. So we have a type name. A type name can be a real, int, boolean, string, long. These are all our so-called built-in types, so they're built into the language. And then we have this last guy that's ID, which allows us to do the user-defined types. In this example, real would equate to real over here, and the A would equate to the ID in the grammar there. So this is a valid type declaration section based on the grammar. It may not be semantically valid, but syntactically it's valid. And part of what you're doing on this project is checking for semantic errors, semantic validity, basically. Now, in the variable declaration section, it must start right here with a var. With actually the string var is what it's expecting. Just out of curiosity, what is var? What would you? It's yeah, but just know this value right here. What do you call that? Close? Say? Almost. Not necessarily what I may not be clear with what I'm asking, but it's a token, right? So if we come and look down here, a var should be here somewhere. Var is right here. These are all our tokens that we can have in the program, and the var itself is equal to var, which kind of means that it's equal to, kind of like I did there with my example earlier, but var is kind of equal to the string var. So we read in the string var, and the token will be var. All right. So we have the variable declaration section. It starts with a var, and then it can have a variable declaration list, real similar to the other one. If one thing to note, well, let me ask. Is that still a valid? Is that still syntactically valid based on the grammar? Yeah, that's right. Right. Yeah, so we have a var. We have a var here. Then we have to have a variable declaration section which doesn't have an empty string at all. So if var is there, you have to have some kind of declaration in there. And then a declaration, again, kind of like the type declaration, is made up of an ID list to the left-hand side, separated by a colon. And then in this case, the right-hand side has a type name, right? You go variable name, colon, whatever type it's going to be, and semicolon. And these are all the valid possibilities for the type name. So that ends that part. The next part is called the body. We get back, we've gone through the type declaration section, the variable declaration section. So we've completed the declaration portions, and now we go to the body. Do we have to have a body of the program? Yeah, exactly. So there's no epsilon here for body, assuming there's not anything listed below, which I wouldn't do anything that tricky today. But yeah, and it has to start with an L brace and end with an R brace, which are those two right there. And then in between it all, it has a list of statements. Same question, do we have to have an actual statement? Yeah. So you can't have, you won't have, or it's syntactically invalid, sorry, for that. And then in the body, we can have all sorts of statements. We can have while statements, we can have do statements, switch statements, conditions, just kind of like a normal programming language. You know, you could have while and then now the spaces, it doesn't look at the spaces at all, it ignores the spaces. So you could have something like that. And that still falls within this language. You have a while statement, starts with a while, and then it's got this condition portion. Condition can be just an ID, or it can be a primary, primary is an ID, a num, or a real num. And then a relational operator is greater, greater equal, etc. Not equal. Interestingly, I remember this now. What's missing from rel-op? Yeah, double equals are just equals, right? I have to fix one of my examples, I think, in this document now. I'd forgotten about that. But yeah, there's no actual equal in the language. Okay. So the while, so I can't actually do what I did here. We could do that. And then while, or y equals 8. So for the start part of the program, for the parsing part, you're going to have to you'll take in these values, but fortunately for the grammar, they've coded most of it. So most of what you're going to have to do for this is you're going to have to handle while statements, do statements, and conditions. Personally, I would start with conditions, because while statements and do statements both rely on conditions. And check to make sure that you kind of have those coming in the way you're expecting, and then move on. The way you'll do that is in the actual program that we've given you, you're able to print out the parse tree. And so for most of this stuff, it'll build the parse tree, and you just kind of have to mimic it for each one of these sections. It sounds kind of intimidating, but it's really not. It's pretty straightforward because you get all this code that they've already given you, and you can kind of just mimic what it's doing and do your own thing. And it is a recursive descent parser, but kind of like the real world, you get it halfway done because somebody left in the middle of a project, and you have to figure out what they were doing and how they were thinking about it, and then just kind of mimic it so that everything's consistent. But your job will be to take care of the while statements, do statements, and then the switch case statements are bonus for implementing that through the whole process. What else? Any questions on that? Pretty good? All right, moving on. So, these are all the tokens that are possible. What is the difference between real num and then int versus and real? Say again? What's the difference between a real num, an int, and a real, looking at the definition that we have up there? Do what? Yeah, so a real num can have a decimal. But what's a real? It's just a string. So, looking back up here, this token, when it reads in, is a real num. Whereas this is just a real, right? That was a weird distinction that you kind of have to make doing this program that I struggled with when I was coding it. Int is just the string int that's coming in. That token is just representing that type, right? But this 7 is an actual, it's not an int. It's a num token. But its type is int, right? So a num is just a num. That's just the format of the literal is what we're looking at. And so when it meets this format of a literal, we get the token num. And then from there, semantically, a num means that it's of type int and that it can have that implication on other things.
So do we have to implement token also?
No, it's done. Yeah.
So we get whether it's real or number.
Yes. But you have to make that. You have to know what to do with it when you get it. You do something different with a num with just this literal value. You handle that differently than you would handle when you see int. But the important thing is that num is of type int, and real num is of type real. So that when you see this equals, you know that to type check that y better be a real. And in this case, if we look, A is defined here, and it is a real, so that would type check. But yeah, real num is the actual literal value, num is the literal value for an integer, and then int and real are just text strings that are telling you what type the variable declaration is. Important note too, int and real will, if it's syntactically valid, if everything's working, if the code coming in is syntactically valid, int and real will only appear in the variable declaration, in the decl section, right? In either the type or the variable declaration section. It'll never appear, you'll never see validly, the int word in the program body. Same with real num and num. All right. Yeah, the types are first declared, then you have the variables, and then the body of the program. Interesting, just side note, with while statements, a while starts with a condition and then has a body. That's the same body we're using up here. Or just so technically when you have a while statement, you have a body within a body. Kind of feels a little recursive, doesn't it? A little bit. So explicit types are not built-in types, so they're not int, string, num, boolean, any of those. They're whatever you call them. And they must appear in, on the left-hand side in the type declaration section. So to define it, to be an explicit type, it must be up here and it must be on the left-hand side. To be an implicit type, it has to be on the right-hand side and not be somewhere already up there. And we'll get into this a little bit more with a couple examples coming up. So looking at this example, T1, what is T1? It's an ID. Is it implicit or explicitly defined? Yeah, because it's on the left-hand side and it's of type int. But this guy isn't defined anywhere above. So it has to be an implied type. We don't know at this point what it is. The goal will be to figure it out, but at this point we don't know. And then you can also have an implied type here. So if it's on the right-hand side here, and it hasn't been previously defined, then it's a implied type as well. Or implicit types. Explicit variables are declared in the ID list of variable declaration. So of a variable declaration right here, the guys on the left-hand side, whether one or many, are part of the ID list of a variable declaration, and so those are explicit types. I'm sorry, explicit variables. And then down here, we have implied variables. Because these guys have not been defined anywhere up in the variable section, and they just appeared in the code. So here are the rules that cover what we just kind of intuitively talked about. This first rule is for explicit types. So T1 and T2 above is any appearance of the name in the left of colon ID list, part of the type declaration. So that's a declaration of type. This is for explicit variable declarations, as we see right there and right there. First appearance of a name in an entire program. So if it just appears and it's part of the type name over here or over here, let's see which one. Yeah, and type decal first. So then that's an implied type. Then this rule covers the second implied type, number 4, if it appears in the variable declaration section on the right-hand side. And then last, first appearance of a name inside the body of a program. So it hadn't appeared anywhere else. You see it for the first time. It's a variable declaration. That's the assumption. Any other appearance of names is considered a use. And then it excludes built-in types. So kind of applying those rules, let's see what we can figure out about the variables that are here. So what are we doing here? Yeah, so we can even write explicit. And it's what's its type? Yeah. So what about here? Say that again?
Either implied or implicit.
Either implied or implicit? Which one? So an implied type has to appear on the right-hand side and has to not appear anywhere before it in the program.
So it's implicit.
Well, this implied or implicit's the same, it means the same thing. Explicit. Explicit means that it's,
Already,
it means that we're, what does explicit mean? Explicit means that we're stating it directly, right?
like
So yeah, so this one is, again, it's an explicit deck of B. So B is on the left-hand side, not the right-hand side. So we're setting it equal to something. We're explicitly defining it, but we're saying that it's a type of A, which a type of A is a type of int. Yeah, exactly. Does that make sense? And then, what are we doing here? Wow, that can't be right. Can't spell. I don't think I spelled any of the ones up there right either. Explicit declaration X, what's its type? B, which is a type of A, which is a type of int. They're all equivalent. They all mean the same thing at this point in this program, right? So you could...
Is it wrong to say it's explicit deck of X type int?
Nope. In fact, you could maybe, in your program, once you figure that out, you could take each one of those B's and A's and just replace them with int. You know, say if you were keeping some kind of table of what was going to what, you could go back and look for all the A's and be like, well, I know A's are ints. So you just replace them all. Might make your life a little easier. Just an idea.
so we create different sets of different built-in internal types of a variable like int, real, etc. And we can create a set of all the variables.
Yeah. A set of all the variables that are of that type. Yeah, and then search it if you need to know what type something is. Definitely be one way to do it. So this guy, again, easy part, explicit deck of, wow, I don't like that word apparently, of Y. Its type, what is C? Yeah. I don't know how to do this. This is C or something, just so that we know. It's not defined anywhere else. What about here? What do we have? Give you a hint. The section is declaration versus use. So what are we doing here?
Use of what?
Yep. Anything else? Are you using anything else?
Yeah, but I don't know how to elaborate.
It's okay. So yeah, we're using both here, right? They're appearing after they've been defined. Anything after it's been listed above is a use of it, just to kind of clarify terminology. And that's the whole point. The whole point of going through this section like this, as painful as it feels, is just to really clarify declaration versus use because of how it's used in all the terminology. It's important for the program. So this guy, what are we doing here? Use of Z. Anything else?
Yeah, no, that's it.
Anything else? think so, yeah. You said, is that an implicit declaration of Z? Yeah, exactly. That we are implicit declaration of Z of type, what? It,
Oh, no, real.
close? Getting there.
Number?
Close. What is the type of num? Int. Yes. There we go. Woo. All right. Last one. Yep. Yeah, and Z. Yeah, and 5. It's not. Is it a variable or a type? No. Is there anything in this statement that is not defined above? Yeah. What is the type of Y? I'm sorry, the type of W. Type of W. Yeah, it has to be a type of int, and actually we'll get into that in a minute. That's just an intuition thing right now. We have rules, these constraints C1 versus C5. Actually, we'll go look at it right now. So C1, the left-hand side of an assignment, should have the same type as the right-hand side. That applies there, and also this guy. No. Yep. Yep. No, that's not the one. Oh yeah, C2. Plus, minus, whatever implies that, so m times 5 implies that m is of type int. And then the type of an expression is the same type of its operands. So in this case, where you have this, it makes it equal to that. So not only because of the 8.0 that means B is a real, but that also means by this the operation that R is a real as well. And so that's what makes W a real. The language will use structural equivalence, which you guys have started talking about in class. And now we've got these constraints. What these constraints do is they establish this intuition that we were kind of using on the section above of when does some kind of use mean that the variable, we can infer something about the variable's type. So the first one, when you have a left-hand assignment and a right-hand assignment, so let's see. I was doing it. Okay. So you have m is of type, which type? Yep. And then operands of an operation, like we were talking about before, implies that m is of type int here. And then operands of a relational operator should have the same type. So R had better be a real here, or this implies that R is a real. Condition should be of type Boolean, so we have a while statement with a condition. This variable, we imply, is a Boolean. This one was really important for me. The condition one was a nice way to solve some of the problems, like in homework, was to find that condition and kind of exploit it to infer about other parts of the program. And then when you have a switch statement, that next value, that next token, has to be an int based on the format. And then we talked about the type of an expression. The result of a relational operation between two variables is a Boolean as well. So this is what allows us to do, the while statement with greater than, less than, kind of like we did on the first example. Num constants are of type int. This is when you have the 5 up above, it's of type int, so that you can infer everything else from that. The same with real. The assumption is if there's nothing making them equal, by default everything is not equal, unless there's some rule that makes them equal. So the first part of the program that we're doing, you have to implement parsing for a while statement, the condition, and the do statement. And then optionally for extra credit, the switch statement, case, list, and case, which is all just basically a switch statement. The rules or instructions in here strongly recommend that you get the parser working first. I diverge with them a little bit here. When I did this project, I didn't do that. So take my advice with a grain of salt. I sometimes look at problems a little differently than some people, but I thought it was much easier just to get it working, just to get the basic parser portions working and look at the trees that were being printed out and actually have some tests of that, and then start trying to play with all the typing stuff on a really simple programming language as input, and worked back from there, and then added while statements, then added conditions. Added conditions first after that, and then while, and then do, and then the switch. Does that make sense? That's not what they suggest. I understand why they don't suggest that. That's just, it was easier for me to approach it that way. Both ways are totally valid. The key point here is that your parser has to be completely working, or you won't get full credit. It has to pass all the test cases, or you lose 50% credit. So somehow people were dumbing it up, dummying it up to work, which wasn't right, and so now they have test cases to test it.
So we can use our first step for the in the 23 way. Because the correct pass is something, so we need first.
I had somebody else ask me that, and I said no, but yes, actually you can. Just use your first, you could stick this grammar, if you wanted, into your project 3, and it should spit out your first and follow sets, right? And actually, I believe what you could do is you don't have to worry about type and all that stuff, so you could really just focus on these guys, maybe create a top, maybe take body, and then actually just take it minus the declaration part, and then put in the parts that you want and see the first and follows from that. And that should get you pretty darn close if you want to do it that way. It's way better than calculating it by hand. And the nice part of having a fully working one from 3. Okay. So that's the parser. We have 8-ish minutes left. I can kind of go through the code a little bit that you get from them on the parser. We can look at the parser a little more in depth, or we can look at the rest of this. I guess I am going to post this document. I wasn't going to originally, but I've done several things. This is basically the requirements document with a bunch of my just kind of notes for doing this. The other option is we could go, since you guys probably won't get here before next week, we could just go over these next week. If you want to look at the code for the parser a little bit. I know the last class, because I did this yesterday afternoon, was, a little intimidated by the whole parsing thing and having to write their own and do that stuff. But what do you guys want to do? Parser? Parsers? Parser? Single? Okay. Let's hope this works. Oh my gosh, that's tiny. I don't think I can make it bigger. No, it's probably some setting. Is that even readable? No. Yeah, there's a setting I can... Let's just do this. So all this stuff you've seen in all your other, it's got the get token, it's completely working, scan ID or keyword, get token, all this great stuff. This section. So this section prints out the parse tree. So the parser that they've already built is building a parse tree. This section prints out what that parse tree looks like. And there's already code in here to actually print it out. But these are all the parts that they've already done. And then they've left for you to do to print out the parse tree when it's each one of these statements. While statement, do statement, condition, case. So there are quite a few different node types that we have for the different ones. So they have different structures, actual structs associated with them that are in the syntax.h file, that are in the header file. That's where those are defined. So this is that file. And we can see a bunch of these different structures that are in here. So I believe, fortunately, body node's already there for you. So as part of the while statement, that's already there. You've got statement nodes. That's awesome. Structure's already there. So all you got to do is populate the structure. Do we get lucky on anything else? Look at that. Case node structure is already there. While statement node structure is already there. So you already know what you need to use structure-wise. It's more about doing the parser. That's actually pretty nice. I didn't remember that. All right, so those are all the print statements. Look, there aren't that many. See, it's really easy. It's really not that bad. You're just in these, you're just printing out the appropriate tree branch or whatever. Then in here, these are your structures for extra credit. Or I'm sorry, this is your parsing area for extra credit. So you have to implement this. What I would do, well, like I said, I would start with the condition node and then go look at something that might be equivalent from the other ones that they've already done and see if I couldn't kind of figure out from looking at like the expression node or something else kind of how to build, what they're looking for. But your first and follow sets will make it pretty easy too. This has a main in it already. So you can run this right off the bat. Pull this code in, put it wherever, compile it, it'll run, should run, and then you could even start inputting simple stuff just to see what it does and build from there. Let's, we can go really crazy here and try it. What was it? It was T.C. Oh, I need to change. Let's, I'll do this. What was it? Semantic. So the GBB is just an alias for GCC with a bunch of parameters that I use. I just like it being in 32-bit. If I can put it in 32-bit, was the main reason I used it, so that if I end up debugging it, it's not as long. It's just kind of habit. So we can run it in theory. And it's waiting for input. And that's this part that came back was coming from the parse tree, so that we kind of know that the parse tree's got in it what we're expecting it to have in it. And it works. The basics. So what I was talking about was I took just what was working and I took a test case like this and then started parsing the parse tree for my own stuff. It is kind of nice. They've already built you something that prints out the parse tree, so maybe you could repurpose that. I don't know. Maybe to print out what you want it to print out. Might work, or at least for part of it. I don't remember what I actually did. It just kind of occurred to me. But you will need to keep track of your variables somehow. I mean, just printing it out's great. Having it in the parse tree is great, but the whole point is the semantic aspect. Questions? Not too bad. Maybe. A lot to do now. The huge key is getting started early, as it was on the last one, so that if you run into issues, weird tests. This one, for me, was not as hard. I think the test cases aren't as sneaky. The other one, I feel like the test cases were a lot sneakier, playing into, things that, implied things that we might not think to check. I don't think we understand what programming languages look like and feel like a lot better, which is why I thought this one was easier, because you can create test cases. It's a little bit more straightforward to create strange test cases. Plus, at least the tokenizing part is all working. You know that part's working. So, that's pretty much it.